Woo! Double angles, double the fun. So fun that this is the second time I'm recording it because there was a lot of crackling, digital crackling in the last video. So I'm hoping that by disconnecting my mic, reconnecting it in the Loom software, that this does the trick. But we'll find out. Hopefully I don't waste another 20 minutes of my life. Alrighty, but for you guys, I want these videos to be as enjoyable as possible. All right. So double angles, much like our sum and difference formulas, you can't just like double it or you can't just split it apart and add them together, right? It doesn't work out. As we said here, you know, sine of alpha plus beta does not equal sine of alpha plus sine of beta. It's not that simple. Okay. Now the same will be true for our double angles, and we're actually going to use our sum and our sum formulas to derive these double angle formulas. Okay. So let's think about this. If it's going to be a double angle, right? Like we're talking about like sine of 2 alpha, right? Well, couldn't I just say that's the same as saying sine of alpha plus alpha, right? So what if I took alpha instead of equal to beta and replaced the beta, substituted alpha in place of the beta in that sum formula? I could then, you know, see what happens mathematically and derive the double angle formula for sine. Let's do it. So let's say this. Say I have sine of alpha plus beta, right? I know that that is sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. All right, I like it. Let's continue, shall we? Now, my next move is I'm going to substitute in alpha for my beta, and I'll do that on the right-hand side as well. Here we go, and boom. Now, what do we find? Well, sine of alpha, cosine of alpha is the same as cosine of alpha, sine of alpha, right? Because multiplication is commutative. So, over here, I've got sine of, well, that's 2 alpha, which is what I wanted. And then over here, I have 2 sine of alpha, cosine of alpha. Boom. There is my formula. Woo! First one down. Gave me goosebumps because it's so exciting. All right. We can use the same thing for cosine and for tangent. Let's do it. Why not? Because that's just fun. I will do some pausing and just writing things down because it's kind of the same process, a little different. All right. So cosine of 2 alpha. So that would be the same as, let's say, cosine of alpha plus alpha, right? And if I were to expand that using my cosine sum formula, that would be, and I'm going to actually jot this down over here. It's cosine of alpha, cosine of beta, minus sine of alpha, sine of beta, right? That's my cosine sum formula. So now I'm just replacing all of my betas with alphas. I'm substituting in alpha for all my betas. And voila. So that would end up being, let's see here, cosine squared alpha minus sine squared alpha. And that would be my cosine double angle formula. Now, for my Pythagorean identities, I can actually get a couple more versions of this one. We'll write it down here in just a sec. I'm not going to derive that now, but we will have 2 more of them in a nice little box. You'll be able to write everything down in one nice spot. Let's do for tangent now. For tangent of 2 alpha, again, I would split it up. And for reference, I wrote down our tangent sum formula off to the right there. So now what I have is I'm going to substitute alpha in for all my betas. And voila, there we go. So now I have 2 tangent of alpha over 1 minus tangent squared. That's a weird alpha. Not that my alphas have been that great. So I got tangent of 2 alpha, and boom. Look at that. We got ourselves the tangent double angle formula derived from my tangent sum formula. Woo! Man, we're deriving. We're deriving. Driving and deriving. I don't even know. Don't drive and derive. That's for sure, right? No texting and driving. Don't derive and drive, right? We could probably barely do this on your own right now without any other activities happening. All right. Here are our double angle formulas. We have sine. We've got cosine, as I said. Now, these 2 up here, those are derived, not what we drive, from our Pythagorean identities. And then we got our tangent one. So Feel free to jot these down. I definitely would. Don't feel free. Just do it. Just do it. Just do it. Pause it. Do it. We're going to do example 1 now. All right. In 5, 4, 3, 2, 1. Okay. So algebraically, we're going to show that cosine of 2 theta is indeed equal to 1 minus 2 sine squared theta when theta equals 60. So we're going to do that with an actual measure rather than just derive it. So let's go for it. So what I'm going to do is I'm going to substitute in 60 for theta. So on my left-hand side, I'll have 2 times 60. I know that's 120, but I'm going to, just to show it, I'm going to write it out like that. And then we have 1 minus 2 sine squared of 60. Remember, we're not squaring the 60. That's like sine of 60 all squared. So on my left-hand side, I have cosine of 120. And I'm just going to work with that left-hand side. That's going to be what? Negative 1/2. It's in the second quadrant, so it's negative. And then over here, I have 1 minus 2. And then sine squared, well, so sine of 60 is going to be root 3 over 2. Square it. So that gives me 1 minus 2, and then this is going to be 3 over 4. And now, got to do a little bit of stuff with fractions here. Again, if you're uncomfortable with your fractions, find a 4th grade or 5th grade, whatever, maybe second. I don't even know what grade they do it in. Relative, sibling, friend, neighbor, I don't know. They could probably help you out, though. And I've got 6 over 4, that's negative 3 over 2 simplified. You could have also done boom, simplifying. And I end up with negative 1/2. I got to watch out with my fraction burns, though, because watch me make a mistake. All right. Negative 1/2 equals negative 1/2. It's true, and it will be true for any measure, okay? It will be true. We could prove it algebraically without an actual example, but sometimes it's nice to have real numbers to make that connection. Okay, let's go. Example 2. So with these, it's very much like something we did in our other ones where we're giving you like the expanded formula, and we're going to go back the other way. So 1 minus 2 sine squared of 20, that is a cosine double angle formula. And if you don't remember that, boom, that's right up here, right? That's the first one. So I know I can go back to cosine of 2 theta. Well, theta is 20 in this case. So I'm going to have cosine of 2 times 20. So that's cosine of 40 degrees. Done. That's it. That's all we're trying to do there on that one. The second one, and I'm going to change colors here because it's getting monotonous. That would be my sine double angle, right? So since theta is 35, I'd have sine of 2 times 35. So that would be sine of 70 degrees. And lastly, that one is again a cosine double angle. It's one of the other ones, right? It's this guy right here. So my cosine double angle, well, my angle here in this case is 3t. So don't freak out about that. It's just a variable, no big deal. We'd have cosine of 2 times my angle, 3t. So that'd be cosine of 6t, and we'd leave it just like that. Nice. Example 2, Dunsky, Dunzo, Continuo. I don't know. All right. And remember, although some of them will end up evaluating, this one said leave answers in terms of sine, cosine, or tangent. That's why they're left with the trig functions there, right? We're not trying to find an exact value. None of these are going to be exact values. But this next one says evaluate the expression. We are going to get an exact value for this one, or we'd have to plug it into our calculator. It'll be exact in this. So this here is the tangent double angle formula, right? So what's my angle here? My angle is pi over 8. That's my theta. So I'm going to have tangent of 2 times pi over 8. And that's going to be tangent of pi over 4, which is just, that's a 45 reference if you like degrees better. 1. It's in my first quadrant. Root 2 over 2 divided by root 2 over 2 if you're a unit circle person, or 1 over 1 if you are a special right triangles person like myself. Your call, though. Be your own person. All right. A couple more examples. This next one's a doozy, though. It's got 3 examples in one. 3 for the price of 1. That is a deal. When sometimes Jewel has ribs, buy 1, get 2 free. That's 3 for the price of 1. I've got like 8 slabs, 9 slabs, or probably 9 then, unless I made one. Slabs of ribs in the freezer for just a special occasion. Maybe it'll be coming up soon when it's not so cold and I can fire up the smoker. You know what I'm saying? Let's continue with the math. Let's continue. All right. So I have if cosine of alpha equals 7 over 25. And alpha is between 0 and pi over 2. That's the first quadrant. Find those 3 double angles, right? Sine of 2 alpha, cosine of 2 alpha, tangent of 2 alpha. First, I think drawing the triangle would be a solid idea. And thankfully, we had restrictions on alpha which is that right there. Putting it in the first quadrant, I've got my adjacent over my hypotenuse. And if we remember honors geom, triples, 7, 24, 25. Woo! Woo! I like it. Alrighty. So now for sine, you got to remember our sine double angle formula. Sine of 2 alpha is equal to 2 sine of alpha cosine of alpha. And I find it easy to write, or helpful to write that down. So now all I need to do is just put in, well, what's sine of alpha? That's 24 over 25. And then what's cosine? Well, that's 7 over 25. You could either get that from looking at the triangle or the OG problem. And now I got to just do some multiplication. Now that denominator is 625, but that numerator gets a little bit fishy over here. 336, got my cheat sheet where I already wrote it all down. Nice. Done. Whoosh. New color. We'll go with green. Okay. Time for cosine. Now, it's up to you which of the three you want to use. But here's where I'm thinking, okay? If we scroll back up here real quick, so I don't have to write them all down. If we look at these, keep in mind, I'm going to have, for sine and cosine, it's going to be over 25, right? My hypotenuse is 25. And I'm going to be squaring it, so that's 625. Now, if I use the first two, one of the first two, I have a 1. I'm going to have to put that over a common denominator, so 625 over 625. Or the third one, they would have both end up being over 625 anyways. So I think I want to use that third one there, right? Which one of the three you use is about which one's going to be most advantageous to you, okay? Which one's going to make your life easiest? Go with that. And sometimes you don't pick the right one. It happens, okay? I don't know where my work went. There it is. Okay, it's loading. Don't worry. Woo! Okay. So I'm going to pick the one that works for me. That's the last one. That one seems easiest for me. So I'm going to write that out, and I would have cosine squared alpha minus sine squared alpha, and now I can just go ahead and substitute in. So I've got 7 over 25 squared minus, and that was 24 over 25 for sine, and that's squared. Cool. I got, what's that, 49 over 625 minus, I think that's 576 over 625. Double check. Yes. Alrighty. Got to know the perfect squares. So now I end up with negative 527 over 625. Lovely. Fantastic. And again, you would have gotten the same answer either one of those three. That one just seemed easiest to me. But hey, maybe you were like, dude, why would I do that? Why would I square two things? I'd rather just get the common denominator. And that's fine too. All right. Totally up to you. Totally up to you. All right. Last one. Tangent of 2 alpha, as we know, is 2 tangent of alpha over 1 minus tangent squared alpha. And again, we're just going to substitute things in. Tangent is going to be 24 over 7. So let's plug and chug. So we got our tangents out. We got the 24 over 7 substituted in for each tangent. Now let's do a little bit of work. We've got, 48 over 7 all over. And that's going to be, the 24 over 7 squared is going to be over 49, right? 576 over 49. So I'm going to jot that down. 576 over 49. And the reason why I did that is because I can then change 1 to be 49 over 49. I'm thinking ahead, adding and subtracting fractions. Got to get that common denominator. Okay. So now I can do a little work. Let's see here. I'm going to have 48 over 7. And then if I think I had a little bit, check this out. I already have this math done in my numerator for me. That was negative 527. Now my denominator is going to be 49, but if I'm going to be dividing by a fraction, I multiply by its reciprocal, and I get 49 up here and negative 527. And if that just blew your mind, feel free to pause the video and make sure that that makes sense of how I multiplied by the reciprocal after putting them together. So that's going to reduce. And then away we go. Let's see here. 48 times 7. What is that? Let's take a look at the cheat sheet here. Negative 336 over 527, right? I just put the negative up in the numerator. No big deal. I like it. Wonderful. Awesome. Uno mas example, children. Uno mas. I know You're just so sad the video will end soon. Alrighty. It's a proof. And actually, you know what? Let me back out just in case you guys need to jot anything down from this. If I went too fast, whatever. Feel free to pause it, take a screenshot, take a picture, be that kid that's like, yeah, I'll totally look at these again in my phone, and you won't. Notebook is a good thing. All right. Example 5. So I'm going to take a quick screenshot of our cosine formulas. So we have the 3 of them to look at because we're going to be using those to help us prove that this is true. All right, last one. Sorry for the bit of background noise there, guys, and that problem. I couldn't stop going, you know. I was so into that problem. So I had to strap up with the mask for a little bit because people were printing something in here. Anyways, let's finish this one out, hopefully with no interruptions. All righty. So we've got 3 different options here. So we got to kind of think ahead as to what we're going to get. Now, with tangent squared of A in this case, right? We're not using fancy alpha anymore. Think about maybe a step prior. I often suggest that in like geometry proofs too. Like, well, think of a step before or maybe even 2 steps before. If I had sine squared A over cosine squared A, that would get me tangent squared A, right? So that's a goal that I could possibly get to. And obviously there's a few things that would work out well or seem to work out well here because I got a lot of sine squareds and cosine squareds. One is jumping out to me in particular. And it's this middle one here. And here's why. If I put that one into the denominator, if I substitute it in, my ones will cancel out, and I'll be left with 2 cosine squared theta. So if my numerator happens to become 2 sine squared theta, I will get my tangent squared A. Sorry, we're changing variables here. And I will be good to go, right? If I can get that numerator to be 2 sine squared A, boom, we're ready to rock. But I already know my denominator is in pretty good shape. So let's go with that one, kind of take a leap of faith here that it is going to work out. And I'm going to go with blue on this one. All right. So I would have 1 minus, and then I'd have 2 cosine squared A minus 1 over, and then I'd have 1 plus 2 cosine squared A minus 1. Lovely. And that equals tangent squared A, or we so hope anyways, right? Well, that's what we want to prove. So now my denominator, the ones end up canceling, and I'm left with just 2 cosine squared A. My numerator, however, I'm going to have to distribute this -1, giving me a positive 1. So I get 2 minus 2 cosine squared A. I've got 2 2's. I'm going to factor that out in the numerator. 2 times 1 minus cosine. Oh, snap. Do you see what I am seeing? I sure hope so. 1 minus cosine squared A is a rearranged Pythagorean identity. So that is going to be sine squared A. Let's substitute it in. So now I have 2 sine squared A in that numerator over 2 cosine squared A equals, cancel those bad boys, and I'm left with tangent squared A equals tangent squared A. Bingo, bango. I'm gonna draw that. Whoop, boom. Mic drop. If there was a mic to drop, I'd drop it now. I know I said that once before, but whatever. Hope you guys enjoyed it. Second take. Hopefully there's no crackling in this one. Otherwise, I don't know what to do. I'll be very sad. Have a wonderful day, guys. America, freedom, rock and roll, Costco. Follow Riverdog Jane on the gram, and have a wonderful, wonderful day. Keep living the Raider way. I'm just gonna stop.